Hello, my name is Dan Pip with Geoprobe Direct Image. Today I'm going to walk through the process of cleaning the switcher valve within the low-level MIP pulse flow controller. This process is a good proactive maintenance item to perform on the controller maybe every year or two depending upon the usage of this controller. Particulates can make their way up the trunk line and get in and cause blockages within the system. This can be observed by a loss of peak response, probably coupled with the MIP pressure not dropping when the system moves over from sample collection into the transport mode. So if you've been seeing something like that, there could be a blockage in there, and we're going to go ahead and show you how to get this all cleaned up. Let's go ahead and begin the process. Here is the pulse flow controller used with low-level MIP. We will need to get inside to access the switcher valve, which means we must remove the two screws on either side of the lid, allowing it to be removed. The easiest way to access the valve is when the front panel is removed, and to do this we need to loosen two gas fittings, an 1/8 inch detector gas supply line on the back panel, and the 1/16 inch detector supply that's going into the flow sensor. This should allow us the room that we need to move the front panel away once the four corner screws on the panel itself have been removed. You will need to remove 4 of the 6 gas line connections on the valve using a 1/4 inch wrench. Make sure you label their position first. The lower 2 ports are coupled together and will not need to be removed. Here is a new valve and motor body where we can clearly see the Allen screw that holds tension on the collar. The head of the Allen screw will be located on the left side of the valve as you face the front of the controller and on the underside of the collar. You will need a 9/64 inch Allen wrench to loosen it. Loosening this collar will allow you to pull all of the switcher components from the valve for a thorough cleaning. Once the collar has been loosened, the valve body should slide off easily toward the front panel. Now we'll be able to begin to see the components that switch the gas flows in low-level MIP. There is a squared shaft fitting that mounts onto the motor, and on the opposite side there are 2 separate notched components that will move back and forth, linking the trunk line return to either the vent or detectors. As you look at the Teflon fitting, it may be fairly obvious which slots receive the gas from the trunk line, as they are going to be quite a bit dirtier than the other slots. Now you can begin to clean the Teflon switcher fitting. The grooves exposed to the trunk line gas will likely be much dirtier than the others. You can use a cotton swab and methanol to clean out the grooves, and you can also use a stiff bristle nylon brush to help loosen and remove dirt, followed up by a cotton swab and methanol again. Continue this process until no residue remains or the cotton swab comes back clean. The 6-port valve is the next component that we'll need to make sure is clean and free from blockages. By shining a light into one of the ends of the valve, you should be able to see light through all of the openings. Since it is possible for condensates, water, and other particulates to make their way up the trunk line, these ports could be blocked. Ports 1, 2, and 6 are the ones that the trunk line gas will travel through. You should be able to use a fine guitar string if you need to open up a port. I would then typically take a paper towel and insert it into the center of the valve and inject methanol or water followed by methanol through the 3 ports that the trunk line gas travels through. The paper towel will allow us to be able to see if any dirt comes out, and also suggest using a cotton swab, one with methanol and a dry one, to wipe down the inside of the valve body. Also looking to make sure it comes back clean. Once you can see light through all of the openings, you should be good to begin reassembling the valve body. We can now begin reassembly of the switcher valve. The first piece will be reinserted from the back side of the valve and will engage within the motor slotted fitting. It can only be inserted in one direction. When you look at the front of the valve, you'll see that the slot which this Teflon switcher engages into. This could go in one of two ways. Choose the best, cleanest slots available that'll line up then with ports 1, 2, and 6. Now you are ready to reinsert into the collar on the motor. Once the pins line up with the slots, rotate the valve so the threaded port number 1 is in the 12 o'clock position. Next, you will tighten the collar around the valve using the 9/64" Allen wrench. The Allen screw is again located on the left side of the valve as you face the front of it and on the underside of the collar. Tighten until snug. Next, locate the proper gas lines as they had been previously labeled and rethread by hand into their proper ports. You will come back with a 1/4" wrench and tighten another 1/4 turn at most. The valve reassembly will then be completed once you thread in the front knurled fitting, which holds all other parts in place if this has not already been reinstalled. With the 6-port valve reassembled, now we will need to replace the front panel and reconnect the two gas lines that had been disconnected. There is an 1/8" detector gas supply line on the back panel and a 1/16" gas line that leads to the flow sensor that need to be reconnected. Rethread by hand and then tighten with an appropriate wrench. Next, I'm going to supply power to the unit, and on the front panel with the switch in manual mode, I'm going to switch the valve between vent and detectors to make sure it appears to be switching properly and sounds correct. With the valve actuating, we can screw in the front panel. We will then need to check to verify that the valve is switching in the proper direction. We'll check that next in the software and monitor our gas flows, so of course we'll need to connect the detector gas supply and trunk line gas supply to the back of the pulse flow controller, along with the trunk line or a loop between the trunk line supply and return. Once we're in the software, the pulse flow controller here is in manual mode. Trunk line flow is on and operating at about 50 milliliters a minute with detector gas at 20 milliliters a minute, so we can see a significant difference between the separate flow paths. At this point, the valve is set up to direct the trunk line gas to the vent, so we should see the 50 milliliters a minute going out the return flow sensor, which we do. The detector gas would then be directed to the GC. When we switch the valve to the detector, we can see that the GC flow is now directed out the vent, leaving the MIP flow from the trunk line headed to the detectors. If the path is opposite, you can loosen the collar and remove the valve, and you will have the two fittings that we had out earlier to clean. And the one behind that is a slotted fitting that sits on a square shaft of the motor. Turn this one 90 degrees and you should be able to return the path to the correct direction. Hopefully this video has given you some confidence in being able to go ahead and clean the valve system within the low-level controller. But if not, or you don't have the time to do it, please feel free to contact us here at Geoprobe and we can set up an RMA and get it in and get it taken care of for you. Thanks for watching.